Morning.
Hi, Mr. Rosenthal.
Hello. Give me 1 sec. Let me pin my video.
Good morning, Mr. Rosenthal.
Good morning. All right, there we go. All right, you have a warm-up up there. Which of the following vary directly? So this kind of makes it, attaches it to experiences you've had. So you can try to get a conceptual linkage yet another time in another way. I think we're making lots of connections with this chapter.
Wait, Mr. Rosenthal, I have a question because, like, for the amount of gas in a tank in liters and the amount in gallons, that would just be like the relationship between the amount of gas, correct?
Maybe.
And then, like, a number. Oh.
You guys can discuss it. I don't mind if you guys talk, using the Zoom here to talk about it.
I remember we did one like C in class one time.
Uh-huh.
It was during like when we were talking about proportions.
Probably, yeah, because proportionality and direct variation are similar.
Yep.
What does it mean to vary?
Very directly.
Well, the vary means to change. So directly means that it's immediately when you put something, immediately when you change one thing, another thing changes because of it. So that links us back to input-output, independent variable, the dependent variable y depends on what x is. So think of y changing. That's what the word vary means, to change. Think of y changing because x changed directly.
Yeah. Oh. I can't see a D.
The total price of tomatoes and the number of pounds.
Well, like the price per pound does not change.
It's always the same price per pound.
Yeah.
Yeah, but
The number of pounds can change.
Yeah.
So the price per pound can change. If you buy something.
But the price of the tomatoes does not change.
One at a time, guys. One at a time.
The price of the tomatoes does not change even when the number of pounds changes.
I mean, like, there's one case where it might, like, if some restaurant's going to buy a bulk amount of tomatoes or carrots, it might change, but.
Yeah.
We don't add
It does not
residually.
One at a time.
Well, like for C, the price per pound of carrots and the number of pounds, the price per pound does not change, but the number of pounds can change. But for D, the total price of tomatoes and the number of pounds, and if you're like basing the price off of the number of pounds, then the price will change based off the number of pounds if you're paying accordingly to the number of pounds.
You could have like a half pound or a quarter pound, and that could change it.
Yeah. If you're paying based off the total number.
Yeah.
Wait, maybe you guys can start talking about how do we answer this question? What are some ways to check?
If if
we change one and see if the other one changes.
One at a time.
You can give x and y. You can give an x value and then.
Yeah, the y something has to depend on another, and then one thing has to be changeable.
Yes.
All right. So what would I do? What would be a?
You would change one of the values and see if the other one changes.
Okay. Change. Okay. So see if one thing affects the other, changes the other. Okay.
For C, wouldn't the price per pound of carrots be a controlled variable?
Something that doesn't change, you mean? Something that stays
The same, because the price per
oh,
pound of
like
carrots.
a constant rate of change?
Yes, it wouldn't change, but like the price per pound wouldn't change, but the total price might change. Like the total price might change, but the price per pound won't change.
You're saying that one
Pound would change, but
so could we use the first strategy that was mentioned?
price per pound would change.
Would one of these change the other?
Yeah, it could change.
I mean, like
Would
if you change the price per pound.
I mean, if there's a lot of people buying carrots, they're gonna raise the price of carrots.
Yeah, so I get, yeah. If they're really desperate.
And if you buy a lot of them, the price per pound is way cheaper.
No, let's get out of
Okay,
recon.
hold on. Let's change the rule then. Let's say that does it necessarily show direct variation? Okay.
No.
The carrot
what is
market
that?
has
So if
been
it's not for-
inflated.
If it's not for sure, then we're going to say no.
Mm.
So which ones are for sure showing direct variation? What's another strategy?
A, of course.
How about something that is linear and starts from the origin is a test to test these out?
Yeah, that's what I was gonna say. Because like if there's like zero, like if you do like if it goes to the origin, like for A, the amount of gas in the tank in liters and gallons. If there are 0 liters in a tank, there's gonna be 0 gallons in the tank.
How about fitting this equation, the y equals kx equation? If you can fit it into this explanation, then it varies directly. Okay, so let's start out on these. A, the amount of gas in a tank in liters and the amount in gallons. Can I multiply the amount of liters
By 3.78, I think.
by something? You don't even need to know what it is.
Something.
And it would be in your agenda, by the way, I tell you. Can I multiply the amount of liters by something to give me the amount of gallons?
Yes.
Yeah.
The answer to that is yes. There's some, and that would be a scale factor. There would be some scale factor that I can multiply the amount of liters by to tell me how many gallons it is.
I know what to do. Now I know what to do for C. I know what it means.
All right, let's wait. We'll hold that and we'll let you share that when we get to C. Let's talk about B. The temperature in Fahrenheit degrees and in Celsius degrees.
No.
Yes, they vary directly.
Okay, we have an opinion that they do
No.
vary. We happen to know that the Fahrenheit temperature, you can get it by taking the Celsius temperature, multiplying it by 9/5, and adding 32.
But
that's
y equals mx plus b.
It is y equals. Thank you for seeing that. I appreciate that. So is that direct variation?
No.
No.
Why not?
Also, I was
Because it's being added, so it's not on the the B's being added, so it's not on the origin.
There's a y-intercept.
Exactly. You both were saying the same thing in different ways.
And I was also gonna say.
If you look here, nothing there. It's 0, right?
Mm-hmm.
Here, when C is 0, F is not 0. When C
is 32.
0, right, so at 0 degrees Celsius, that's freezing temperature. The Fahrenheit temperature is not 0. It's
32.
Yeah, so this graph does not go through the origin. Okay?
Just because they meet at another point doesn't mean that they don't meet at the point that's 0, 0. They can meet like anywhere else, but they're not meeting. If it's not meeting at 0, 0, then if they're not the same at 0, 0, then it's not going to be.
Hey, but listen to this. Remember our first criteria? We said to look if it varies directly. That means that we can test it by seeing if one thing changes then the other thing changes. That wasn't enough. That was not enough, because here when you change the Celsius temperature, you do change the Fahrenheit temperature, but you don't change it proportionally because of that plus 32 on the end. Great, great.
So the equation is like the best route sometimes.
Well, right now that's working for us.
Right now.
Yeah,
Yes.
and understanding how that's all connected helps as well.
Mm-hmm.
Okay, let's go to the price per pound of carrots. The price per pound is like a rate and the
Yeah,
number of pounds, okay?
that's the.
That would be like X. So knowing K and X, does changing one change the other? K does not change because K has to be a constant. That's the price per pound. Price per pound is the K. X is the number of pounds. I can change the independent variable, the number of pounds, but I heard you guys having that conversation that, well, some of you could see where if you buy in bulk, I think that was Oliver, that somebody might change the K, but not in most cases, your price per pound is fixed for the time at the time you're shopping, right? Now you could choose between different deals, all right, but then they would each have their own equation in which that deal you were working on would be fixed. So let's say we are buying in bulk. They're still going to give you, okay, if you buy this many, then we're going to charge you a certain price per pound. They're going to fix it at some point. While you're buying it, they're not going to change it. Once you agree, okay, I'm going to pay that price per pound, that stays constant. Okay, once you buy over 50 pounds of something, well, now at 51,
It's incredible.
at 51 pounds, that price is going to stay the same. Maybe at 60 pounds, it goes up again, but there's going to be a range where that's going to stay constant. So you are going to get a K there that's not going to change within a range of pounds, right? So this is not going to vary directly. This money amount won't vary directly as the pounds change. That's not going to change, right? So what you're looking for is for them to give you a Y and an X, not a K and an X, right? This C gave you a K and an X. So this price per pound is not going to change when the number of pounds changes. Okay, so this does not represent direct variation. They could both fit into.
Your shirt is
They
incredible.
could both fit into. The price that you're going to pay varies directly as the number of pounds you buy, which I think is what D says. The total price, that would be Y. Now we're talking about tomatoes now. Notice I didn't put anything here. So this was here, could have been carrots in problem C. Now it's tomatoes. It's the same thing though. The total price would be Y, and that would change as you change the number of pounds, right? And K would stay fixed, right? This would be the price per pound, right? So this varies directly. The price of tomatoes does vary, change, right, Everett? It changes when you change the number of pounds you're buying, right? And check. How do I check to make sure there's no plus B on the end?
I don't know.
Well,
Make sure that there's no tax.
Make sure that it's zero.
what you would do is if I buy, what happens when I buy X is 0 pounds?
Then why?
Then you pay $5.
Why should be zero?
What? Well, yeah, if you were paying $5 when you bought nothing, when you bought no tomatoes, then you would show that it does not vary directly. But
Yes.
logically, if you're buying
Yeah.
nothing, why would you be paying anything?
Yeah, exactly.
To stand in the store.
Entrance fee.
Well, you can try to create a strange scenario if you want.
Donations.
But it's not reasonable.
But yeah, and that's that would
Tarnation.
okay. So I would say D does show direct variation because of that logic that you do. If I buy no pounds, I'm probably not going to pay any money. That gives you a 0, 0 origin, right? That gives you a no y-intercept situation. Okay? And then let's look at E.
Why does C not vary directly?
Because they're giving you the K and the X. One, changing the number of pounds that you're buying of carrots doesn't change the price per pound.
Oh.
So Y varies directly as X. In this Y equals KX equation that we've been working with lately, we say that Y varies directly as X. But when in number C or letter C, they're giving you a K and an X. K does not vary because K is a constant. K is a constant of variation. It means that that's the whole reason why we learn the definition of constant and vary. Why was that an important question to start this lesson? Thank you, Everett. It was important because Vary is really important here. K does not vary, right? So when they say which one varies directly, you need a y and an x. You cannot, K does not change when you change x. Y changes when you change x. All right, now let's move on to the last one. So they need to give us a y and they need to give us an x. A number and its reciprocal. Okay, so they're saying, does a number change when you change its reciprocal? Reciprocal. And we're testing, is that going to be true?
Yes, it does change.
Okay, it changes. Does it change directly?
Yes.
Okay.
When the reciprocal. Oh wait, so the reciprocal would be. So the reciprocal would be x, and then the number would be y. Is that what?
But K has to remain constant. This is the most difficult case.
Yes.
Letter E. But look, K has to be constant. All right.
The
It
thing
won't
is,
always
it's
be
like,
constant because they're different. Each number has a different reciprocal.
Okay,
so
so
you're
watch,
gonna have to
watch
use
this.
different numbers in order to get the reciprocal.
Watch this. If that's 5 and you're saying 5 varies directly as its reciprocal, what's the reciprocal of 5?
1/5.
1/5.
Okay, solve for K for me right now. Take 10 seconds. Solve for K. What would K have to be?
5/1.
It would have to be 25.
1/5 of 25.
Someone's fire alarm is off.
Oh, right.
1/5 of 25 is 5.
5.
Or multiply by 5 on both sides and you'll get that. 25 is equal to
Where did this come from?
the what?
Where did 1/5 come from?
Because I'm plugging in
It's an
an X and a
example.
Y. I'm plugging in like we did yesterday. I'm trying one solution. If X is 1/5, then the reciprocal is what this is saying is 5. Right?
Why?
Because that's the definition of a reciprocal. And that's what this is saying, a number and its reciprocal. What's the relationship between them, right? Does one directly vary as the other? If so, then you're gonna have a constant that never changes, K. Okay, so we're examining another aspect we have not been talking about this whole time, is that here's something else that has to be true. The constant must stay constant. It can't change.
Yeah.
So now watch what happens now if I try to put in a different one. What if I put in 1/4? What's the reciprocal?
4.
4. Okay, so let's go back to our equation. Our equation is y is equal to, we found the constant is 25.
But it's
So
not.
if it varies directly, then it will always be 25 times x. Is 25 times 1/4 equal to 4?
No.
It's
No.
not. So
No.
the constant would have to
Not
change
at all.
for this to be true. The constant would have to change for this to be true.
Uh-huh.
Yeah. Okay, so if that's true, then this is not direct variation. It's actually called inverse variation. It varies inversely, but we're not doing that this year. In the green book, that's for Jasper, they do talk about these problems. They have inverse variation and they have joint variation.
Oh.
Y can vary as 2 separate variables when 2 separate variables change. So this is a little bit of bonus you're not responsible for, but that's inverse variation.
Yeah, that's what I was like doing when on my paper.
That is
Like,
not direct variation,
Yeah. It was,
okay? Because you know when we try to do that, what's going to happen when you have the other case was, I guess, this.
yeah, that's what I was doing on, like, when I was trying to give like what the equation would be, because if it's basically like the reciprocal of y would be 1/y.
Yeah, it would be 1/y. But okay, so we could not keep our constant when it was always had to be the reciprocal. Then K would always have to be a different number to get Y out, okay? But this is called inverse variation, if you want to know. if two things vary inversely. So that would be one of those work problems that a lot of you already know how to do. When two people work together, how much time is it going to take to do the job?
Oh.
That's inverse variation. That's why you have to flip those over to do that work problem.
Oh yeah.
Because those vary inversely. All right. The more people you have working, the less time it's going to take to do something. All right. And then you have joint variation, where y can vary. You always have to have a constant there. Now, the constant could be 1, and if it's 1 times something, then it's not going to matter, right? So you can always disregard k if k is 1. Then it won't show up. So you can always say, well, what if something is equal to something else? Then if y is equal to x, you might say, well, there's no k. If x is 2, y is 2. But there is a k. K is 1. Okay, so there's always going to be a k there, some constant that never changes there. All right, here's joint variation. Y varies directly or varies jointly as, let's say, x and w. And you can have other combinations. So joint variation can be y varies jointly as x and w, and inversely as c. Right? It can get very complicated, right? But it's easy to solve these because they're going to have to tell you x, w, z, and y, and you solve for k. Once they tell you everything, then you can figure out what k is. Turn that off, please, or I will remove you. Whose sound is that coming from? Did that show up?
Anyone who's unmuted.
Who?
It's Charlie.
Yeah, Flynn, mute yourself.
I didn't play any music.
Okay, hey folks, we cannot have the music playing. I have to remove the students that are doing that. Please don't do that again. That's the second time that person played that music. That was intentional. Please don't do that. Okay, moving along. All right, so that was a nice little warm up. All right, have you guys heard of Kelvin? You've heard of Celsius, you've heard of Fahrenheit. Have you heard of Kelvin?
Yes.
Yeah.
So they say 0 Kelvin is absolute 0 in the universe.
No.
Yeah, I don't think there's I don't think we've ever measured 0 Kelvin before. I don't know. We have to look into it.
Yeah, because molecules are always moving.
Never before. Frozen. So 0 Kelvin is basically the limit. You can't go negative. 0 is the baseline when you're talking in 0 degrees Kelvin.
Mr. Rosenthal?
Yeah.
Is it? I heard that when molecules start like getting close down to like 0 degrees Kelvin, they start like behaving in weird ways, like
I'm sure they do.
like floating, like sort of like clinging to like beakers and like floating around inside them.
Well, if you think about what 0 degrees Kelvin is, it's
Molecules.
zero movement. Right? 0 movement.
Yes.
And I think if there's 0 movement, then that time stops working for that, whatever is at 0 Kelvin.
But that's not possible. Time.
That's what I'm trying to say.
Exactly.
Molecules are always moving.
Time is attached to movement. What is time if not
Time is relative.
movement of things from one position to another position? Right? That's what time is. It's connected.
Maybe time continues.
So, and that it's connected to temperature, okay? Because temperature is the measure of the speed at which things are moving, right?
Yeah.
Okay.
So you're saying it goes against the laws of time for something to be at 0 degrees Kelvin?
Yeah, I mean, and see, these are really interesting conceptual, philosophical things to get into. But right now, let's get into this problem. The volume inside a balloon, that's how much space it's taking up. All right, so when you blow up the balloon, you're increasing the volume because it's taking up more space. Okay, so the volume inside a balloon varies directly. I'm going to start writing that. Volume varies directly, that gives me a K, as the temperature. There it is. See that? V equals KT. K is my constant, T is my X, P is my Y. V varies directly as temperature. That means as temperature increases, what happens to the volume of the balloon?
It also increases.
It increases, and it's by some multiplier that stays the same. Okay, maybe it's double the temperature is you get double the volume. I doubt it, highly doubt it. That was just a guess. Or it can be times 1 1/3 pi, something like that. Who knows what, I don't know what it is. Maybe we're going to find out right now. Okay, we probably are. It looks like that's what we're going to find out. We're going to find out what that is. The volume of the balloon is 3 liters. Here we go. Actually, you do the problem. I'll read the problem and I'll let you continue from there. The volume of the balloon is 3 liters at a temperature of 300 degrees Kelvin. What is the volume if the temperature rises to 350 Kelvin? Go. So basically, you're going to need to know K. Once you have K, then you can find out the volume for 350 degrees Kelvin. So you basically have to locate that multiplier. Given a temperature and a volume that go together, that's an ordered pair, right? They're giving you an X and a Y. X would be the temperature, Y would be the volume, liters. So 303 would be your coordinate. Sorry, I need to stop and let you do it.
Wait, Mr. Rosenthal?
30.
Get it right.
You know 300 degrees Kelvin is actually 83 degrees Fahrenheit?
Oh, do you have a converter?
Yeah.
Nice.
Okay, Google.
Thirty seconds.
What is K?
K is your constant. It's your multiplier. It's what you would, it never changes. It's what you, when you know what temperature you have, you would multiply K to it to get the volume in liters.
Mr. Rosenthal, is that 303 or 300?
300 degrees.
Okay. Thank you.
Can we type in chat our answer?
Yeah, that'd be great.
Wait, so we're just solving for K, or are we doing the...
Did I get it right?
We're answering the question. What is the volume in liters if the temperature rises to 350?
Okay.
And time. All right, so let's see what we get. 3 liters is equal to K times the temperature of 300 degrees Kelvin. All right, I better get rid of my units because we're going to have some matching here. Okay, now I solve. How do I solve this? Well, I need to divide by 300. Good thing we know how to do that now. K is equal to, take a 3 out, 1/100th. Or, if decimals, 0.01.
Isn't it 303?
It's 300.
Oh.
Okay, so K is 0.01. It's 1%. 1% of the temperature gives you the volume in liters. And of course, this is only Kelvin and liters. It would be a different answer if you were changing the units. Okay, so now that I know that the K is 0.01, my multiplier is 0.01. So my equation changes. It becomes V is equal to 0.01 times the temperature. 0.01 times the temperature. So no problem. They give me a temperature of 350. And I can take 1% of that by moving the decimal twice. So that becomes 3.5. So the volume would be 3.5 liters. 3.5 liters of volume the balloon would reach.
Formula to use.
The what?
How do you know which formula to use?
By finding K. They told me the volume varies directly as the temperature. So now I know it's Y equals KX.
But how many of these formulas are there?
Just one for direct variation.
Ah, okay.
Y equals kx is the formula.
I saw some other ones. Are you sure that's the only one?
Give me an example of another one.
I forgot.
Okay, when you come up with that, I can answer that question, but I can't answer if I don't know what you're referring to.
Oh.
To what you are referring.
Well,
Okay.
pretty easy.
What?
I said otherwise it was pretty easy.
I'm sorry? Can you do another one?
No, I said whatever.
No, tell me.
I just said otherwise the problem was pretty easy.
Oh, yeah, that's good. All right, try this one. Here you got another one. The number of kilograms of water, W, they're telling you what variable that is, in a human body varies directly as the total body weight, B. So you can make an equation. I'm not going to do it for you. A person who weighs 75 kilograms contains 54 kilograms of water. How many kilograms of water are in a person weighing 95 kilograms? Go. Can you solve this with a proportion? Yes or no? Is this a problem that lends itself to proportionality? Is direct variation similar to proportionality?
Yes.
Okay, so then yes, the answer is yes. A proportion would also work to solve these problems.
Yes.
Wow, 20 minutes just flew by.
It did.
Hey, Mr. Rosenthal, it says the number, wait, it's hard for me to read. The number of kilograms of water varies directly.
Let me increase the size to, let's go to 225. Is that helpful?
Yes, thank you.
Yes.
Formula. Am I wrong? I think I am. Is it the same formula?
Is it?
I think so. You only said there was one.
Does it say direct
No.
variation? Is it talking about direct variation?
Yes, because it says varies directly.
If it says varies directly, then yes, you're using y equals kx.
Yeah.
But instead of y and x, you're using w and b. W varies directly as b. W varies directly as b.
Or it's W equals.
Can
Okay.
we type our answer in the chat?
Sure. A person who weighs, so be careful. The person weighs, you might put that in for W just because they both have a W. But body weight is B. So the person who weighs 75, that's this. And the amount of water is W. So if you switch those around, you're going to get it wrong. Now solve. Okay, let's see. I'm seeing a 3 going into both of these. 3 goes into that. Let's see. 18 times. 3 goes into this one 25 times. Yeah, so that's what K is. Now that I know what K is, rewrite your formula. W is equal to 18 over 25. That's your K.
72%.
Oh yeah, that's 72%. You're right. Times B.
72% times 95. 72 times.
Yeah, and now the person weighing 95 pounds, you can do
68.4.
18 over 25 times 95 will get you your answer. You can do it as a fraction, or you can do it as that decimal problem. Let's see, as a fraction, take a 5 out, and you would get 19. 19 times 18 divided by 5. What do we get? 72. 8, 15, 9, 1. 342 divided by 5. Okay. So that's going to give us 6. I know I'm going off the screen here. 8. 68.4. Okay, so W, which is the water weight in kilograms, would be 68.4 kilograms.
Hey.
Okay, and I see that a lot of people put that in the answer. Good. Excellent. Okay, any questions about this? No? Okay. I move forward. Forward, forward.
Yay.
Onward. Okay, now to 9.5. So what lesson are we on? We're on lesson 9.5.
Wait, it was 68.4, right?
It was 68.4, yes. So 9.5 is slope-intercept form. So that means now we've really hit home the direct variation. Now we're going to throw in a b, a y-intercept, with all of our problems. Okay? And if y-intercept ends up being 0, slope-intercept form is still okay. Right? So now, Everett, we are switching to this slope-intercept form. Okay?
We did this at the beginning of the year.
We will. It's because it's super, super important.
Yeah.
This is our foundation for linear equations. Okay? There are other ways to write linear equations. You have, this is slope-intercept form. We have standard form. That's a linear equation.
We're at 60 participants again.
That's good. A, B, and C are constants. So the only variables here are X and Y, just like here. M and B are constants. They don't change once you find what those numbers are. X and Y represent the different points along the line. Infinitely many solutions are the X and Y, and we represent the X and Ys as coordinates, but not the M's and the B's, not the A, B's, and C's. And there's even another one called point slope form that we're going to need to know. Okay, so y minus some coordinate you do know is equal to the slope times the x minus some coordinate you know. It goes with that coordinate.
Wait a second, haven't we been doing this y plus mx, y equals mx plus b for a while now?
You just learned it at the beginning of the year.
Because I'm choosing to connect it throughout the whole curriculum to what we are learning at the time. So that by the time we actually get to it, which is that moment now, that it's very familiar to you, and you know all the connections start to come together. Hopefully, you're already feeling that. We brought in proportionality. We've been using fractions and decimals and percents along the whole way.
Could you distribute on the right side of the last one, on the y minus y1 equals
yeah, let's do that.
mx minus mx.
Yeah, let's do that. Distribute. Okay. Add y1.
That wouldn't change the answer, right?
Add y1 to both sides. Y is equal to mx. These two together, none of these are variables, really. These will be constants later. These x1 and y1 will be numbers given to you. The slope will be given to you. Okay? So that means that these will all equal some value. Call it b. See it?
Oh, cool.
Mm-hmm.
Oh, so that's the y-intercepts.
Yeah. Now check out, we're not going to learn this all together like this, like we're doing now. You don't have to memorize any of this stuff right now. I'm just showing you that there are different ways to write linear equations. solve for y with this one. Go ahead, get ahead of me. I'll give you a 10-second head start, and then I'm going to solve for y in standard form. It's going to be a little messy.
What do you mean by solve for y?
This one solve for y.
How do you solve for that?
Use all the rules that I've taught you throughout the year.
By solving it.
And try to write it in slope-intercept form. So that the x part goes first and everything else comes after. This one, though.
No.
All right, you got a head start. I'm going to subtract ax on both sides. Now it's gone over here. So all I have is by is equal to. I'm going to use the commutative property, c plus a negative ax. I'm going to do negative ax plus c. It's starting to look like mx plus some constant. What I name the constant doesn't matter, right? It's going to be some number. It doesn't matter whether before I know the number, whether I call it b or c, it's just some constant. Same thing there, all right? Now, how do I solve for y?
Divide by y.
Divide everything. Divide everything by b.
B minus.
1y, now it's solved, is equal to negative a over b x plus c over b. And in this case, negative a over b is the slope. C over capital B is the same as whatever that is. They're just numbers that come out to be some constant.
Oh.
Yeah. All right. So those are the different forms that you are going to see, but slope intercept form for lesson 9.5 is only the one that you're really used to already, the y equals mx plus b. So we're going to get rid of all this right now, and we're just going to focus on this. And my job is going to be to try to spot things that I haven't mentioned all year yet, because I think you're going to know all this stuff. So it's going to be challenging for me to find something new and interesting for you. For others that are have been struggling throughout this whole time, hopefully this gives it to you that next time where it's just, okay, I'm starting to get this now. So there's something for everybody hopefully here. All right. Slope-intercept form. The slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So this line, y equals 2x plus 1. 1 is the y-intercept. It's the b.
So isn't all we can't see?
Oh, thank you. All right. So y equals mx plus b is slope-intercept form. So when you see y equals 2x plus 1, that 1 is that number I told you. You're going to have a number. You're going to have a number there. It's not going to be a b. It's going to be a number. That number is where the red line crosses the y-axis at 1. The 2 is the slope. If you write 2 as a fraction, why would I do that? Why don't I just leave it 2? Because I want to see it differently. I want to see it as a delta y and a delta x.
Yes.
Or a rise over a run. So that from this point, I can change my y by 2, positive, as long as I change my x by 1 also, and guess what where my finger is? Back on the line. I can change it by up, my y I can change by 2, but I can't just change my y by 2 because now I'm not on the line anymore.
I have
I
to
can
change
also change my x by 1, okay? Right? And I can do it in different combinations. I could do up 6 over 3 because it equals, those are equal, right? So as long as this comes out to a 2-to-1 ratio, then I will always end up on the line. So I can take a point here and go up by 6, 1, 2, 3, 4, 5, 6, as long as I go over 3, 1, 2, 3, and my finger's back on the line. Okay?
Yeah.
So that's the slope part, and it's really important to make the connection. When you see that, you should immediately be able to graph the line without a t-table. You just put a 1 on the y-axis. Some students will put it on the x-axis because they don't have a lot of experience. And then they do it on tests, so they lose a ton of points doing that. And then later on, they don't make that mistake anymore. So that means you really need to do your homework. You need to practice it. Do all the problems if you can, not just the evens or odds. Okay? So, but then once you get that 1 and you realize, oh, that's always on the y-axis, the y-intercept, not the x-intercept. Then from there, I can use the slope, write it as a fraction, and go up 2/1 and make another point. Then draw your line. Done. That's the quickest way to graph instead of making a t-table. You need to know how to do both. Questions before we move on? Okay. All right. An equation with a y-intercept that is not 0 represents a non-proportional relationship. We know that already. When b is something that's not 0. An equation of the form y equals mx plus b, where m is the slope and b is the y-intercept, is in slope-intercept form. Okay, great. Got that. Got it. All right, let's do example 1. For these 3 problems, I'll give you 60 seconds. State the slope and y-intercept of the graph. Actually, you only need 20 seconds. Go. I just want the slope and y, jot it down on your paper for each one. A, just write, don't even have to, if you want to write the original problem, that's fine. I want the M and I want the B. The M and the B.
Do we just have to say what it is based on what we see?
Okay, yeah.
Oh.
Okay, here we go for A. Let me see what you wrote for A. Write it in there.
Wait, Mr.
Write it in the chat.
I have a question. For C, is that a negative 2x or positive?
Negative 2x.
Okay.
For A, you're writing for A, what is M and what is B? M is what? B is what? Give me both. There we go. Good. Good. Paulo, that does not make sense.
Wait, for A, is it 1/4?
Wait, we're writing it in the chat. All right, so now we can write it in. The slope is 1/4. The B is -6, not 6. Some people put that the slope is 1/4 x. They put an x there. That's wrong. Incorrect. That gives you a wrong answer. The slope does not include the x. Okay, for the next one, it's 3 and 1. For this one, it's -2 and 0. Questions about that?
Is the last one a y equals kx?
It is. Good. K is -2. If B is 0, then yes. Yes. Moving along. Okay. This one might be more tricky. So I'm going to give you 2 minutes to find these. If you want in the chat, you can say, tell me which one you're answering. Okay? Maybe I should do one at a time. Let's do one at a time. Okay. -4x plus y. Tell me what the slope and the y-intercept are in the chat. It's not in slope-intercept. This might be challenging because it is not in slope-intercept form. You need to put it into slope-intercept form. You need to solve for y. What does it mean to solve for y? Y must be isolated in the equation. Or 2, -4, -2.
Can't see the problem. There's a lot of glare.
Oh, because I got up close to the screen.
Okay, thanks.
Actually, I wrote the problem on the board. Okay. Okay, Haley, it's not you rewrote the equation, but it didn't ask for that. It wants the slope and the y-intercept, right? State the slope and y-intercept. So you would give me m equals b equals. Okay, I'm seeing slope of 4, y-intercept of 2, 4 and 2, 4 and 2, 4 and negative 2. Give me both answers, please, not just one. 4 and 2, negative 4, negative 2, 4 and 2, 4 and 2, 4 and 2, 4 and 2. Okay, let's take a look. Everybody watching? So it looks like we're split. Most people are saying 4 and 2. Some people are saying negative 4 and negative 2. Let's take a look. Solving for y. I'm going to add 4x to both sides. Step 1. Okay, that's 0. Step 2. Use the commutative property to switch these. So 4x plus 2. Now, m is 4. B is 2. Questions? You're going to get a whole bunch of these, so ask your question now so that you can apply it to the next problem.
How did you get them from not being negatives to not be
negative in blue, right? What did I do underneath?
You add 4.
Why did I add 4? What's negative 4x plus positive 4x?
0.
To isolate the y.
I want to get rid of the negative 4x, so I add it. But what do you have to do with the properties of equality? You have a balance scale. If I add value to a side, then you're going to tip the balance. So you add it to the other side, which is what I've shown here. And that's why now over here it's plus when it used to be minus.
Thank you.
Is that okay?
Yes, thank you.
Any other questions? Let's go to the next problem. Okay, the next one is 6x plus y equals negative 3. Mute your mics, please. Okay, take 30 seconds, go. Negative 6, negative 3. Negative 6, negative 6. Negative 6, negative 3. Negative 6, negative 3. Negative 6, negative 3. Looks like there's all agreement so far. Okay, and that's 30 seconds. Watching. This is positive 6x. So it's minus 6x on both sides, or negative 6x, if you want to look at it that way. That makes a 0, which isolates the y. Step 1 complete. Step 2, use the commutative property so that you can put the slope part first, which is the negative 6 part. So negative 6x first, negative 3 second. Slope, negative 6, y-intercept, negative 3. A lot of students will just say 3, by the way. They drop the minus sign. They just don't pay attention to it. That's very common. So don't let that happen to you. Questions about this one? Okay, going to the next one. Y minus 5 equals negative x. 30 seconds. Go. Negative 1, 5, negative 1, 5, negative 1, 5, 0, 5, negative 1, 5, negative 1, 5, negative 1, 5 again, same person, again, same person, negative 1, 5, negative 1, okay. Here we go, time's up. This one's even easier than the last one. You just add 5 to both sides. No commutative property needed. This is 0. You've isolated the y. Here you already have the x part first with the slope here. Okay? So it's negative x plus 5. So the slope is negative 1, because you don't see it there. It's a 1, negative 1. Y-intercept is positive 5. Questions about this problem?
I just have a question. What's the difference between a positive and a negative slope? Is it just like the way that the line is?
Look at my arm. It's going down from left to right. Right? As you travel to the right, my arm is going down. That's a negatively sloping line. Okay? Positively sloping line. It's going to go up from left to right. The rise is going to be positive for the positive run. For negative, the rise is going to drop negative down with a positive run.
But if it's a line, then it's going both ways.
Only, okay, listen.
Oh, wait, no, it's not.
Watch this. Watch my finger. Negative delta y over a positive delta x. Positive on the x number line is going to the right. But if I go the other way, then watch this. My delta y is positive, but my delta x is going to the left, is negative. So whether it's a negative divided by a positive or a positive divided by a negative, the answer is still a negative slope. If I go this way and I start at my elbow, positive change in y, because I'm going up, divided by a positive change in x, because I'm going to the right, a positive divided by a positive is positive. If I start at my fingertips and I go to my elbow, I can do a down for my y, changing my y down is negative, and then changing my x negative, because I'm going left. That's a negative divided by a negative, which is a positive. So it doesn't matter which way you go, right? That's a positive slope. That's a negative slope. What's right in between positive and negative?
A neutral.
Well, what is that on a number line? What's between positive and negative?
A horizontal line. Oh,
Well,
an axis.
On a number line. On a single number line, what number resides between the positives and the negatives?
Point.
On a number line. On a regular old
0.
kindergarten number line. Yes. 0 is in between. So guess what this slope is?
0.
0. Positive, negative, right in between is 0. This is not 0. This is infinitely positive and infinitely negative at the same time. So it's undefined. All right? Next problem.
Oh, okay.
Y minus 5x equals 10. Y minus 5x equals 10 because I said so. It was a joke. Nobody got it.
I got it.
I'm going to go home. Oh, wait a minute. 20 seconds. Go.
That's kind of ironic.
Yeah. 5 and 10, 5 and 10, 5 and 10. You guys are really, you're getting fast now. That's good.
Wish.
I'm trying to just type the answers as fast as I can.
Yeah, I mean, you can see ahead. You don't have to keep doing it. You can see, oh, this is going to go to the other side, and it's going to change from a minus to a positive 5. And that's it. That's the coefficient of x. So that's the slope is the coefficient of x. The number that's a constant by itself is already on that side. So it's going to stay as is as a positive 10. Okay, so students are immediately doing this.
This chapter 7.
No, it's chapter 9.
Chapter 9. Okay, so this is 0. We've isolated the y. We switch these up, 5x plus 10. And you have, this is your slope, this is your y-intercept, 5 and 10. Any questions about that?
Isn't the x 2?
No.
The x, there's no 2 on the board here. That's a 5 and a 10.
No, but
Oh, what is x equal to? You don't know. Remember, there's an x and a y. If you change x, that's going to change y.
so because then you can't change it because you don't know. Okay, that makes
Infinitely many solutions.
Yeah.
Now, if x is 2, this would be 5 times 2 is 10. 10 plus 10 is 20. Then y would be 20. So y is 20 when x is 2. But you don't know, y could be something else, x could be something else.
Yeah.
Okay, moving on to E, last one.
I'm actually getting this, I think.
Good. And then gotta grip that homework.
Wait, how would you solve something with only one variable?
Well, it's a horizontal or a vertical line.
Yes.
So if you get that x is equal to 7,
It's a
vertical line that goes through 1, 2, 3, 4, 5, 6, 7.
It's a
the y-axis.
horizontal.
X-axis. Hold on. This is 7. It's this vertical line here. That's x equals 7. A horizontal line would be y equals 3, maybe. There's 3. There's y equals 3.
But you have to find the x, so it's a horizontal line, right?
If there's only one variable, it's either x or y. If it's x, then it's a vertical line. If it's y, it's a horizontal line.
It doesn't make any sense. Why would it be a horizontal?
Up. Why would this be a horizontal line? What's the slope of a horizontal line?
Up and down.
What's the slope of a horizontal? Vertical is up and down. What's the slope of a line that it's horizontal?
0.
It's not positive. It's not negative. It's right in between.
0.
All right, so 0 slope. Let's take a look at 0 slope. Y equals mx plus b, where the slope is 0.
No.
See that? What's 0 times anything?
It's 0.
So that's gone. So you just get y equals b, which is just going to be some number. So y equals b is y equals a number.
Like, it's just, if y equals 5, then it would just be 5 equals 5.
No, y equals 5. Now, when you have that,
y a value then? Because if
no, back up. See, when you have the slope of 0, we know what that is. It's a flat line.
Yeah.
And what happens to the equation is the x is eliminated because the slope is 0.
Oh, so it can only be a y?
Right, and so y equals a number makes sense for horizontal lines.
I didn't really get that, but okay.
Okay. What type of slope is this?
Positive.
And this?
Negative.
Okay, so right in between should be logically what?
0.
Okay, so here's a horizontal line. You now know it's logical to you that the slope is 0. Now go to the equation. M is the slope, make it 0. 0 times x, no matter what x is, whatever x is, whatever you want to say x is, doesn't matter. It's getting multiplied times a 0 slope.
Yes.
Right? Okay? So that means that the elevation never moves up. It never moves down. As you're changing the x, here's, let's say, x1, and you move it to x2, a second position. Or if you want to say you move it from A to B. What's not going to change is the y.
Yes.
Not going to be any rise. There's not going to be any rise to your delta x. Your delta y is going to have 0 change.
Yes.
So that's a flat line. You're not going to move up or down. You're just going to go right or left only. Okay? What happens in the equation, though, is 0 times x is 0. And all you have left is where you started at b, is some number. So on a coordinate plane, I started somewhere. I could have started at the origin. I could have started up at 1, up at 2, down at -3. Wherever that is, I'm never going to change that. I can only move left and right from there.
Yeah.
Okay, left and right is a horizontal line.
Okay.
Okay, now when you have x's, when you say that you have a vertical line, the slope is undefined. Okay, your slope is undefined. We're getting close to the end here. So
And that's when x has 2 different values.
If your slope is undefined, then it's going to be hard to do this. Undefined slope times x plus b.
It's when when one value of x has 2 values of y.
Yeah, and so what the thing is that this happens when x has to be the same number. X never changes, right?
But that makes it.
Okay, when X never changes and Y can change, that means on an like an Etch-a-Sketch, you're allowed to move up and down, but you cannot move left and you cannot move right, right? You get this vertical line from doing that. That means X has to stay at a certain number.
That knob is broken.
In equation language, when we speak equation language, how do I say that X has to stay 2? X always has to be 2. How would I say that? X equals 2. X is always 2.
But yeah, and it's undefined because it's expanding up and down, right?
Yeah, so I can start at 0. I can start at 0 on the Y, and I can go up from there 5. I can go down 5. I can go down 10. I can go up 1,000.
So then you can't assign any. You can't call it positive or negative or 0 because it's going both ways.
Right. And then
so
X is 2.
Check the time.
Or X is I know what time it is. And X is 2. It just stays where it is.
Okay.
Let's finish up this last problem and then let's see what we have after that. So we're going a little over, but that's okay. X equals 2 plus Y. Isolate Y. Subtract 2 on both sides. Y is equal to X minus 2. Slope is 1. The Y-intercept is negative 2.
Where did you get the 1?
There was nothing in front of the X, so it's a 1, not a 0. There's one X there.
I forgot about that.
Okay.
Okay.
Let's see what else. There's graphs. Let's see what else we're going to be getting into tomorrow. So we'll go to the graph. So there won't be any new homework tonight. There'll be example 4 and then a homework assignment. Okay. Dismissed, everybody. I'm on office hours now. Have a great day.
Thank you.
Okay.
Mr. Rosenfeld, your shirt is incredible.
Thank you. I appreciate that.
What is a circle? Is a circle like a function?
A circle is not a function. It's a set of all points in a plane equidistant from a central point.
Thank you.
Okay.
It's basically like if you use a compass, that's kind of like the same thing as like a circle because there's one central point and then you keep the distance from like where you're drawing.
So let's say the green point, we're going to say the green point is a central point. And it's in the plane of the board. The board is in the plane. Now, I want all the points that are that distance away from the green dot. Whatever that distance is from green to blue, I want all of those points. So if you take your compass and lock your compass into place, which is what a compass does, and you lock it, then you can rotate it, and then your new point that you make will also be that distance. And you can make the point, but the circle is not just those points. It's not a lot of points. There's an infinite amount of them. And I need all of them. How do I get all the ones in between the two?
You draw a line.
But it's not a line. You draw a circle. The circle is the symbol that shows you that you're covering all of those points. So it's not just a set of points. It's a set of every single one. You can't even be missing one of them.
In between.
You cannot have a gap. You cannot have a hole in your circle. So it's every single point. All points that are the same distance from a central point. Now, if I say in space and I bring the point out here, right? Then it's the set of all the points that are equidistant from a central point in space.
That would be a sphere.
That's a sphere, yeah. So the definition of a circle and a sphere are the same, except for one's in a plane and one's in space. Next question.
Wait. Can you do number A, for example?
This is chapter 8 retake up?
No. I will announce it myself in a Zoom meeting when I have.
Okay.
Excuse me?
Uh-huh.
Can you do example 2 for number A? I mean example A for number 2.
6x plus y equals negative 3?
No. 4x plus y equals 2.
Negative 4x plus y equals 2.
Yes.
Okay. You want to isolate y, so you add 4x on both sides of the equation. That gives you a 0 here. 0 plus y is y.
Y equals.
The commutative property says I can add in any order. So I can do 4x
4x plus 2.
So this is your slope. This is your y-intercept. Slope is 4. 4 over 1. That means your delta y is 4. Your delta y over your delta x is a change in 4 for every change in 1. And any ratio that is equal to that. So I could say 8 over 2, right? I could say 2 over a half if I want to. I can make it a complex fraction as long as it comes out to 4 over 1. Based on that.
Thank you, Mr. Rosenthal.
You're welcome.
So you just do the you just add it and then that's it. You just get y equals 4x plus 2.
I worry that you're trying to find, you want some algorithm. Always do this, and next you always do that. You're not going to be able to move through math that way. It's kind of like giving yourself a crutch. It might be a reason why you could be struggling is because you're trying to look for a way that you can, and you know, the math that we're doing is all Common Core stuff. It's all, do you understand the concept of it? And so it's not going to be, yes, you're going to always add, and then the next thing you're going to do is always do that. That's not how you're going to want to think of it. It's not going to be as helpful because when you actually get the test, you're not going to be necessarily given that situation in all the problems.
Okay.
So you have to understand what you're trying to do. I'm trying to isolate y. How am I going to isolate y? I have to use properties of equality.
Okay, Eric doesn't understand why you're trying to isolate y, Mr. Rosenthal. Hi.
To get it into slope-intercept form, we define slope-intercept form as an equation that looks like this, y equals mx plus b. In that equation, we define this form as slope-intercept form. And in slope-intercept form, we notice that y is isolated. So in order to get this equation in that form, you must isolate y. Otherwise, it will not look like that base formula.
Oh, now I understand that because you just have to isolate y by getting rid of the x.
Or anything. In some of the problems, look at letter C.
Could we do letter C?
X was already on the right side. It was the -5. So whatever's with the y, even whether it's an x or a constant, you need to get it away from the y. You need to get it onto the other side. How do I do that? I do it with opposite operations.
So it would be, for number C, it would be y equals negative x plus -5.
Okay, let's examine that. Would it be plus -5? What's -5 plus -5?
Subtract it. It would be subtract -5.
Let's look at that. Y -5 equals -x. Let's first tell me what makes this 0.
What do you mean? What makes
Why were you saying -5? What were you saying that for?
Because that's a -5, a -5.
Okay, so what do I do next?
You have to add
it y.
You have to add it to +5.
Add it. You said the word it. I don't know what it is. Be more specific. Add what to what? Be specific about everything.
Add -5 to +5.
Where is there a +5? I don't see. You're looking at this as a +5?
No, that's a -5, and you have to add it to. I can't. The opposite operation, I think.
So would it be adding 5?
Yes.
On both sides?
Yeah.
Then that wouldn't be plus -5. It would just be +5.
And so y equals -x plus 5.
Yeah.
Oh, I
So
get
the slope, if you don't see a number there, you fill it in with a 1. The slope is -1. The y-intercept is +5.
Okay.
That makes sense? Yeah, definitely.
Bye.
Oh, that's it. Okay. That was so abrupt.
Stop. No, hold on. Hi, I'm here. I'm sitting here with Everett, Mr. Rosenthal. We're just going through the work because, you know, this is important stuff. Yeah. Okay, what about this? example.
We haven't even gotten to that yet.
You haven't done it at all?
No.
Okay. All right. Do you have any other questions for us?